Okay, let's get started. Okay. So last time, let's put the light on here. Last time we stopped at 221, so we're picking it up from 222. Okay. So this time now we have mu of m. Well, first let's get the inverse. Y equals. Actually, you know what I'm going to do? I'm going to call this time. I'm going to call it x equals 2 a sine 1 over y. X equals 2 a sine 1 over y. And then I'm going to solve. Huh? Oh, I keep. Classic mistake. And now I'm going to solve percent of 1 for y. Okay, so now I can make my inverse function. We'll call it mu of m. It's defined as 1 over sine m over 2. Okay, so we want mu of pi over 6 2 pi over 7 and 3 pi over 8. 2 pi over 7 and 3 pi over 8. And we could make these numeric. There we go. Okay, so that's 222 done. Now on to 223. The average temperature in degrees Celsius of a city in the northern United States can be modeled by the function Tx. It's defined as 5 plus 18 times sine pi over 6 times x minus 4.6. Where x is the time in months and x equals 1 corresponds to January 1st. Oh, that's interesting. I would have made it, not x equals 0. So x equals 1 is January 1st. Determine the month and the day when the average temperature is 21. All right, so we want to solve when does this equal 21? Okay, solve percent of 2. Yeah, okay, let's get this numeric. So that's nice that we know 1 is January 1 first. So you see, the problem is though, the months are not evenly sized, but it's quite clear here where x is the time in months. But of course, the problem is some months have 28 days and some have 31, some have 29 and some have 30. So it's how do I interpret months? Should I interpret the 6th to mean like the 6th month? Or should it be like 6 times 30 days? Okay, okay. It's June anyways. So we know the song 30 days has September, April, June, and November. So I'll need to type in 0.69 times 30. That's 20.7. So we know that a 0.0 corresponds to the first day. So is it June 20th? Is that what I need to be thinking about here? June 20th. But the 0.7 would mean it's occurring during. No, it wouldn't actually, because when it says x equals 1 corresponds to the January 1st, it's at the beginning of the day or the end of the day. It's a little bit messy here, the rounding. See, I was kind of leaning towards June 20th, but the answers is June 21st. We have 0.69 times 30 means that we have 20.7 days completed. So we're into the 21st day. Yeah. June 21st. And again, because the nature of sine, if you picture the circle, it happens, or if you picture the graph, goes up, down, and under. So, you know, I can't draw it here, but the hill shape, or if you think the quadrants, all students take care, ASTC, the answer to this would happen in the first and the second quadrant. So we'd have to add 90 degrees, but since we're talking about a year, that corresponds to a quarter of the year, which is 3 months. So basically, 3 months later, is it? No, that's not quite right. No, it's not. Sorry. I need to open up some paper to make my point clearer. So what's happening is we have one answer here and we want the second answer here. So that was 6.69 months, and it's a half year for the first two. So 6.69, sorry, I see where I'm going wrong here. And it's the difference between January 1st being 1. So it's kind of weird, but okay, so this would be 1. And then this would be the start of July. So that would be 8 then. Oh, what a mess. What a mess. So that would be over here. And what answer do we want next? So if we go back to the equation, it's signed to be positive. So yeah, that's to be signed to be positive. So it's positive there. Yeah. Something's fishy. I've done something wrong here, haven't I? Oh, do you know what it is? It's because I'm mixing up x and sine. So like, yeah, okay, I see here. So this guy here, that's the key. A sine, arc sine 8 over 9. So arc sine 8 over 9, that's roughly in degrees 62 degrees. So I was right the first time. If we're just talking about the circle going from 0 to 360, I got about 60 degrees here. I suppose if we put that in radians, so that's about 1.09 radians. So the second answer, yeah, is over here. So I'll have to do a 2 pi minus that answer, 2 pi minus that answer. And that'll give me the other angle, roughly about 5. Sorry, did I say 2 pi? What is wrong with me? Pi minus that. Okay, let's fix this now. So that's about 2.04, roughly 2.05. So those are the two angles. So what I could do, because I'm not really supposed to be doing it on paper, but it was just easier to explain, although I made a dog's dinner of explaining it. I could make a second function here. Okay, and then the difference is I need the second possible situation that would give a sine of 8 over 9, the second angle here. So what I'll do is I'll just do percent pi minus that. Okay, let's see what we get this time. Yeah, okay, so June, July, August. That's halfway through August. 30 days has September, April, June, and November. So that is the 16th. But the answer here is the 15th. So that makes me think that the 30 days has September, April, June, and November. So they said 21st, but this time they didn't say the 15th, they said the 16th. Sorry, they did say the 15th. So I wonder if that's a mistake, because what they've done is for the first answer, June 21st, they rounded up. And August 15th, they rounded down. So the only other explanation I can think of is what I was saying at the beginning, where we need to keep the months the same number of days. So if we define a month as 365 divided by 12, does that fix things up for us anyway? 30.4 days. So let's take the first answer, this one here. Just multiply that by 30.41 and all the sixes. And then the second answer, which was here, multiplied by the same thing. We'll just delete that 0 and that 8. Okay, let's see what we get. 21 and 15. Yes. So, okay. Here's the thing. I wouldn't say that it's wrong, but I'd say the question should state that 1 month is 365 divided by 12. So that really messed things up for us to try and get the answer at the back. Really messed things up for us. Okay, but sure, look, we have the answer now. We matched it up at the back, but it was a lot of work. It was a lot of work to get there. I guess it's the problem when you're dealing with months, isn't it? That's why I would have preferred if the unit was days, then this problem goes away. Yeah, I might submit a ticket on that one. I wonder what other people think. Okay. Two, 4. The depth in feet of water at a dock changes with the rise and fall of tides. It is modeled by this function. dt is 5 sine pi over 6 times t minus 7 over 6 times pi plus 8. Let's check that. Oh, what did I forget? Stephen. Okay, 5 sine pi over 6t minus 7 over 6 pi plus 8, where t is the number of hours after midnight. Determine the first time after midnight when the depth is 11.75 feet. Okay, solve percent O2. Okay. 8 hours. 8 hours. 0.6 of an hour. Percent O4 minus 8 times 60. That looks like 08:37 and a few seconds. Approximately. Let's see, I want to check it on my calculator. 5 plus 18 times sine pi over 6 times t minus 7 over 6 times pi plus 8. Oh, I said 18, didn't I? Yeah. Now, there's a second answer that I don't ask for, but I'm curious to it, so I'd like to get it just for the fun of it. So we'll just change this to pi minus k. So that's nearly noon the second time it happens. Okay. Right, so that's okay. Let me just make sure I type this formula in right. 5 sine pi over 6t minus 7 pi over 6 plus 8. Looks okay. All right. 225 now. An object's movement in simple harmonic motion is modeled by this function. Minus 6 times cos percent pi over 2 times t. S is measured in inches and t is measured in seconds. Determine the first time when the distance is moved 4.5 inches. So st equals 4.5. Then I want to solve percent O2, make it numeric. Oh, it's giving me the negative answer. So minus 1.56 seconds, 1.5 seconds before it began. So we'll need the second answer for cos. So let me just fix that. So for cos, the second answer I believe is 2 pi minus the first answer by using the circle, the ASTC circle. Oh, okay. So that's what, about 1.5 seconds. Yep, that matches up with the answer at the back. Okay. Two, 6. What am I doing for sound? Am I still recording? Yeah. Oh, it's taking longer today. Probably because of that dilly-dallying with the months. So I'm trying to, I'm trying to keep my videos about 20 minutes. I don't want them to be too short because I want to get kind of a good bit done per video, but I also don't want it to be too long because I'm trying to, imagine an amount of work students could do per day if they're studying. So I'm kind of going for the 20 minutes, but maybe I'll just try and push on and get these finished. A local art gallery has a portrait 3 feet in height that is hung 2.5 meters above the eye level of an average person. The viewing angle theta can be modeled by this function.